Hello and welcome to Waka Waka Breaking It Down. Today we are looking at the transformations on an exponential function. So we'll be reflecting a little bit and shifting left and right and up and down, talking about domain and range a little bit, and the rates that go along with exponentials. So it's mostly about graphs, right? And going back and forth between the equation and the graph. You kind of have to have that basic equation down in your brain that y equals some starting amount and then some rate and then raised to the power. But this is kind of the basic we've been working with for a long time, but now we're going to add in some shifting. So I can shift either left and right, or I can shift up and down from that. And on top of that, I could do some reflections with negatives. So I could make a negative to reflect it over the x-axis. I can make this a negative, so I could do that right here. Or I can have a negative in front of this piece to reflect it over the y-axis. So it's very similar to what we did with quadratics and very similar to what we did with square root functions. When we worked with quadratics, we had our vertex form where we had some a, and that a could have been negative possibly. And then we had some x minus h squared and then plus k on the outside. So same kind of idea. And again, we could have had a negative inside here possibly to change things, right? So the negatives kind of, add a little extra level to stuff. But the h and the k were the shift, the h is the shift left and right, and that's always opposite of what you think. So if it's x minus 5, that's actually shifting to the right 5. And then the k is shifting up and down, and that's just like it looks. So if it's plus 5, it's shifting up 5. So that's very similar to what we did before with quadratics and the square root function. We did that as well, same thing. So it should look very familiar. We try to make these problems basic for you because there's a lot of them where there is an algebraic way to solve some of these if I made them hard on you, but we try to make them nice and easy so you can just logically think your way through most of this stuff. So keep the idea of like, what's my y-intercept, what's my starting amount, what's my rate, and has it been shifted up or down or left and right? They kind of all work together, right, to give you the points that you're seeing or what's going on. So let's get to it. So breaking it down, we got y equals 3 to the x, and we're going to shift it up 4 units. So right away, you should kind of in your brain have an idea of some of the key features. So this doesn't have a number in front. So since it's not there, then in reality, it's just a 1, like 1 times 3 to the x, which means that I have the point 0, 1. That's kind of like my starting amount. Remember, we said this is our starting amount. Now that would change if I had some kind of shifting to the on this, like if I was shifting up or down or whatever. There's no number on it. I'm just going to be graphing this for the moment, and then I'll worry about the shifting right afterwards. So for just this equation, 3x, 3 to the x, it would look like this, where we'd start with 1, and then we multiply by 3 every time. So if I go over 1, then the 1 times 3 is 3, right? 2, 3, and I'd be here. And then if I go over another one, I got to take 3 and multiply that by 3, and that would end up way up at 9 somewhere, right? Way up there, even further than what I just drew. 3, 6, 9, it would be way up here, right? Way up there. And then going the other way, if I undo this, like, I've been multiplying by 3, multiply by 3, you can go the other way, but if you do, you have to divide by 3. So if I take this 1 and I divide by 3 going to the left, I'll be at 1/3, 1 divided by 3. And if I go another one to the left, I'd take 1/3 divided by 3, which is 1/9. And if I do it again, I get 1/27 and 1/81 and 1/243. It just gets smaller and smaller and smaller. But the key is it's never going to cross the x-axis, right? So when y equals 0, I am going to have what we call an asymptote. We've been working with asymptotes before. When we did the exponential, or we did square roots, we worked with asymptotes. So same thing here, you're going to have an asymptote. So this right along the x-axis is an asymptote. I didn't make that very nice, but there you go. So this will come all the way like down like this. It'll go through that 1, and then it'll approach the x-axis without actually crossing it. So this is what we have, right? That's just this part of it. Now they're saying we're going to shift it up 4 units. So the whole thing's going to go up 4. This 1 value I had is going to go 1, 2, 3, 4 values up. So my starting amount isn't at 1 anymore. It's up here at 5. And all these other points are going to go up 4 units as well, including this asymptote used to be at 0. Now it's going to be up at 1, 2, 3, 4. So I'm going to have an asymptote up here at 4 now instead of at 0. So everything's shifting up 4. It's coming down here now, and then it's going to approach the asymptote up here at 4. So the asymptote, you really have to watch. The shifting up and down is what's going to change that. So you really kind of want to watch that. That's kind of a big overview of what we're looking at now. So they just want you to write an equation. We didn't have to graph it, but I thought I'd start with the kind of sketching it off so you could see what it looks like. All right, so equation-wise, what do we have to do? The equation is actually easy. All you have to do, take what you had. If they say shift it up 4, then you just say, okay, plus 4. And I just shifted the whole thing up 4. I just want to keep in mind that the 1 is not actually my starting amount anymore because I've shifted it up 4. It used to be 1, but I moved it up 4 to 5. So I would actually have like one of my points would be 0, 5. If I put 0 into that equation, I'm not going to get 1 out of it, right? I'm going to get 5. If I put 0 in for x, 3 to the 0 is 1. So that part would have been 1, but then plus 4 moves it up to 5. Okay, so my starting amount or my y-intercept is not always this number in the front. It's a combination of that along with the shifting. Okay, so we can see it there. I'm going to be jumping back and forth to the answer key, which is over here. Let's go up to number 1. There it is. So you can see that's our answer. Okay, identify the domain and range. Well, that picture, that image I had of the graph is really very good because that will help you with your domain and range. Right, it's something like this. And we said this was y equals 4 for the asymptote. Sorry, that's an ugly 4. That's better. So the asymptote's at y equals 4. So for the domain, that's going in the x direction. It goes to negative infinity, it goes to positive infinity in the x direction. So for the domain, I'm just going to say, so I'll do domain. I'll put a big D for colon, or for domain, and put a colon after it. And then I'm going to use the double R to show all real numbers, right? You could have written it as negative infinity to infinity, but to me, it's easier to just say all real numbers. So that's another way of saying all real numbers, right? Okay, range. For the range, we're looking at the y values of the graph. This never crosses that asymptote. So all my values are going to be bigger than 4 in the y direction. So for the range, put a big R for range, put a colon down. I'm going to say y is greater than 4. I'm not going to say it's equal to, just greater than, because it never will touch that asymptote. It'll get really close, but it's not going to touch it. Okay, another way I could have written that is I could have done parentheses and then start at 4 and go to positive infinity. That's using interval notation to say the same thing. Okay, so domain and range, there you go. That image of the graph really helps, right? It kind of gives you a visual of what's going on. If I don't have the visual, how could I do it? Well, you can make a visual anytime you want, but I also know that normally, just this piece will have an asymptote as 0. And then this piece tells you to move it up or down. So that's telling me where the asymptote is going. So my asymptote used to be at 0, and now it went up 4. So my asymptote is at 4, where y equals 4, right? And that's why our range has to be bigger than 4, because that's where the asymptote is at. Okay, so hopefully that all comes together. The algebra, the graph, the shifting. Okay, hopefully that makes sense. All right, let's look at number 2. We're going to move along now. Okay, now this is one of those situations where you have to write your own equation given some points. I have 0, 6, and 112. The pieces of an equation ask a couple things. What's my y-intercept? Like, what's my starting amount? But you got to remember, the starting amount is not just a. If it was only like this, then a would be my starting amount. But now we're going to have a k on there sometimes. So we have to worry about that and just make sure this wasn't shifted up. How do I know this was shifted or not shifted? Where's the asymptote? We just got done talking about that. If my asymptote is still at 0, right? If that asymptote is still at 0, that means my k value is going to be 0. Why is that important? Well, if the k value is 0, that means that a actually is my y-intercept. I don't have to worry about the extra shifting or anything because it's just 0. It didn't go anywhere. So it makes my job a little easier knowing that a actually is the starting amount of 6. There's another problem we're going to get to where it is not, and you'll see that towards the end. Okay, I still don't know my rate yet, but I know my starting amount from this, right? Okay, so I just put that 6 in there. Great, beautiful. All right, sorry. Okay, how do I find the rate? Well, I have another point. I can use that. So you can just put 12 in here into the equation you have so far. Again, I don't know the rate yet, but I do know after one time period that I have a y value of 12. So I can put those values in for x and y, and I can solve. Just divide by 6, and I'll get 2 for b. And of course, b to the first power is just b. I don't have to do anything with that. So it's just b is 2. My rate is 2. Does it make sense? Well, yeah, 2 times 6 is 12. So yeah, it makes sense. As I go over 1, I'm going to change from 6 up to 12. I'm multiplying by 2. So that's my rate, right? That's my overall rate. So my final equation would be y equals 6 for the starting amount times 2 is my rate, and then, of course, to the x power. I don't have any shifting yet, so it's just kind of a nice, easy example. Like I said, we try to give you easy ones on the test, but there's a couple you're going to have to think through and do a little work. Okay, erase all this and on to the next problem. That idea, right, that the shifting up and down determines where your asymptote is and also determines whether you have something added on the end of your equation, and all that comes together to help you kind of determine where your starting amount is. Just keep that in mind. Okay, just popping over the answer, you can see that's what we had for the answer. Okay, next problem, number 3. Okay, they give us a nice graph, so we can start graphing this out. The first thing I'm noticing is that there is no shift up and down. I don't have, it's like plus a 0. There's nothing here on the end to say shift up and down. That's big because it helps me with a couple of things. One, it tells me where my x-intercept, or sorry, where my where my asymptote is going to be. So in this case, because there's no shifting, I know my asymptote, which by the way is down here. They're asking for that. That asymptote is going to be where y equals 0. That comes directly from the shifting. All right. And that's a good place to start, because if that's 0, then I know this number actually is my starting amount because I didn't shift it up or down any. Like right now we're going to start at 40. So I'm going to write in 40 here, and that's going to be my starting amount. Let's just say though that on the end of this, I had plus 5 on the end of this. So my starting amount wouldn't have been at 40. It would have been at 45. It's kind of a combination of this and this together. I hope that makes sense. It's like if I put a 0 in for x, that's going to be 40, and then plus 5 gives you 45. So it's a combination of this number and that number to give me my starting amount. So, but in this case, it's a 0, so it's just 40 is my starting amount. What are we doing? Well, we're multiplying by half every time. So if I go over 1, I'm going to already be down halfway down to 20, right? That's 20. If I go over another one, over to 2, right, I'm going to do half of 20 and get 10. If I go over another one, I'll do half of that and get 5. And if I do that again, I get 2.5, and then 1.25, and then half of 1.25, right? And you just keep going down. Hopefully you can easily see that my number will get smaller and smaller and smaller, right? Half, 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 half. But it'll never quite get to 0. It'll get closer and closer, but never quite get there. All right, so it's nice to start off with a graph. Graph the equation, label the scales. Okay, so that's 40. This is going by ones, 1, 2, 3. Right? They didn't tell us, if this is hours or years or what. They didn't tell us. And it's already labeled X and Y, so I'm going to leave it. What's my y-intercept? 40. How do we write the y-intercept? I wouldn't just say 40. I would write it as a point. The y-intercept is a point. So let's put in 0 for x. If you have x is 0, you get 40 out of it. By the way, you can always plot points, right? Just put 0 in for x. What do you get? Put a 1 in for x. What do you get? Put a 2 in for x. What do you get? And just start plotting points, right? You can always do like a little on the side. You can make yourself a little XY table, right? And start plotting points to yourself and just say, okay, what if x was 0? Oh, I get 40. What if x was 1? I'm going to get 20, right? And just start calculating them out and make yourself that XY table. All right, so we got the y-intercept, we got the asymptote. Is this growth or decay? Well, you can see it's going down, 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 down. So we will call that decay. How do I know when I just look at an equation? Because the rate is less than 1. If you have a rate less than 1, it's always going to be decay. Okay, so let me erase all that, and let me pop up the nice written solution briefly to show it's the same as what I had. There's their graph. They have a little nicer graph than mine, but same stuff, right? 0, 40 is the x-intercept, y-intercept y equals 0, or asymptote y equals 0, and it's decay because the rate is less than 1. Okay, number 4. Okay, now I'm starting to see shifting. I see this +2. So when it's with the x, it's always opposite of what it looks like. So if it's +2, that means left 2. And then this is shifting up and down. And this one is just like it looks. So if it's a -5, it's down 5. Okay, so I have everything else going on. I have a rate of 8. So every time I move in the x direction, I'm going to multiply by 8. I'm kind of starting at 4 originally, but this is going to get shifted now, right? Things are getting shifted. Oh my goodness. So if things shift, then my y-intercept isn't going to be 4 anymore. It's going to go somewhere else. Let's see if I can maybe do a quick graph of this. So first they say identify the transformations. So they're just starting with the basic 8 to the x. So there's 3 things going on: the 4, the +2, and the -5. So the 4 is a stretch. So we call this a vertical stretch of 4. So vertical stretch of 4. Sorry, I'm instead of writing it all, I'm just going to pop over here real quick. Sorry. So you can see they say vertical stretch of 4. And then we already talked about the +2 is to the left 2. And then the -5 is down 5. So you can see here, down 5, left 2. Okay, so that's what you're writing. You're just writing out what they do. Okay, identify the transformations. Done. Sorry. Describe how the transformations impact the domain and range. Right. So this y-intercept, sorry, I got to take a drink here. The y-intercept, not the y-intercept, I'm sorry. That number on the end shifts it up and down. Sorry, something caught my toe. Sorry. All right, so that shifts it up and down. which changes your intercept. So if my intercept is usually at 0, I keep saying intercept. What I mean is asymptote. So the asymptote is usually at 0, but this is going to move it down 5. So down here somewhere at -5, I'm going to have that horizontal asymptote. All right. Then normally I would have started at 4, like up here at +4. But because of the -5, it's going to like this point wherever it was is going to shift left 2, and it's going to move down 5. So I got to go, not only do I have to go down 5, but I got to go left 2. So I got to go over 2 to the left and down 5. That's going to end up at -1 in the y direction and -2 in the x direction. So that's actually where my starting point is. How do I know? Well, start with this value, and then you can do your shifting around. I can go like left 2 and down 5 using that point. All right, so left 2 and down 5. All right, so that's my starting point. Now, it's a rate of 8, so that's just going to get bigger and bigger. As I go over 1, it's like multiply by 8, and then, or, increase by 8, and then over up 8, over up 8. Well, it's not like slope, not over. It's like times 8, right? So whatever this used to be, it'd be like times 8. So you don't have to be perfect, but maybe if I put, like, maybe I'm curious what the y-intercept is. So a lot of times I'll put 0 in for x and see what that comes out to be. So let's try that. I can tell already it's going to be a really big number. Why? Because I'm going to get 0 plus 2 is 2. 8 squared is 64. 64 times 4 is 256, right? And then I minus 5. So 251. So my y-intercept is way up in the sky, way up at 251. That's just a huge exponential, really, really fast. So how about I try a -1 instead? If I put -1 in there, in for x, -1 plus 2 is 1. 8 to the first power is 8. 8 times 4, 32. 32 minus 5 is 27. So it's still way the heck up there. It's still way up there at 27 somewhere. So you can see this is going to go up really quickly. Boom, 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 boom. Way fast. And that helps me figure out the shape because I know on the other side it's going to approach the asymptote. I'm so sorry about my coughing. Okay, so that's kind of what it looks like. If I want to verify this point that I moved around, I can put in -2 into the x value. The reason I'm using -2 is because I know that's where it was shifted to in the x direction. Plus, if I look at -2 plus 2, that equals 0, and that's what I'm going for. I want to know what's going to make this kind of piece a power of 0. So if I put -2 in there, that gives me 0. 8 to the 0 power is just 1, right? This whole thing goes to 1. And then times 4. 1 times 4 is 4. 4 minus 5 is -1. So I can confirm that point that I put this at right there is really a good point. It's a valid point, right? You just have to figure out the shape of it after that. And that comes from the 8. I can just tell that that's a big rate. It's bigger than 1, so it's going to go up, right? I know it's going to go up. And then on the other side, I know I'm going to be approaching the asymptote. Okay, so that'll help you kind of graph that out and kind of see what's going on, right? All right, so transformations, we already talked about that. So how do they affect the domain and range? Well, when you look at they didn't do the graph here. I thought they had the graph on there, sorry. Let me just do a quick, so our asymptote's at -5. And then we went like we went like this, right? Really fast. Like it was huge. But basically that was the idea. Okay, so domain, that's real numbers again, all real numbers. Because the x direction, it just goes all the way to infinity to the left and all the way to infinity on the right. So that's my domain. For my range, you can see that the asymptote really is the key. So our asymptote was at -5, and then we go bigger than that. So any number where y is bigger than -5. It's not equal to -5 because that would be the asymptote, but it's bigger than -5. Okay, so that's your domain and range. But it comes from the asymptote, really. That's what you're focusing on. If you don't have the graph, you don't want to do the graph, which, I don't have to do the graph anymore. I can just look at this and say, oh, that's where the asymptote's going to be. That's going to help me figure out my range, right? So you can see they have that here. Y is greater than -5. Y is, yeah, so y is greater than 0 is what it used to be, but now it changes to y is greater than -5. That's the true, like this is the answer, right? Nothing else really changes. Everything else is still all real numbers or whatever. Okay, next problem. We're getting there, right? Little by little. Okay, number 5. This is just matching things up. They all have, they have different things going on, right? This is a rate of 1/3, 1/3, and a 3. So right away, you know that the 1/3s are going to be decaying. So they're going to be the ones that go down. But you can see this one has a negative on it, or this one does not. So that negative is going to flip it, right? Where the negative's on the front, that's changing all my y values. So it's going to reflect over the x-axis. So this is what kind of the 1/3 would look like. This is what a negative of 1/3 of the x would look like, flipped over, right? Both of these were shifted down to, so you can see they both kind of shifted down after it was reflected. This was down to, oh, so is the other one. So they all went down too. This one looks like it's down further because it was reflected first. So it got reflected down here to 1/3 already. And then after it was down, then it got moved down to after that. Where the other one started up here. Sorry, at 1, I mean. These started at 1 and then they moved down 2. Versus the one with the negative, that started at -1 and then moved down 2, right? So it started here after the reflection and then moved down 2. So that's why it's a little further down than the others. So I know that this one is your C, this one is my B, and then this one's A. How do I know that's A? Well, it has a positive rate that's bigger than 1, so it's just going to get bigger and bigger. There were no negatives to flip it around or anything, so this is going to be A. So we got C, B, A. Number 6, we're starting with 200. Do I have any shifting? No. So that really is my starting amount. If you want to be sure, you can just stick 0 in for H and say anything to the 0 power is 1. 1 times 200 is 200. So I'm starting with 200, right? If I would have had some value on the shifting, if I would have had something over here, like some plus or minus, then that would have changed my starting value because it would have been shifted. But that's not what I have. Okay, so to get from the next to the next to the next, all you're doing is multiplying by the rate. So I take 200 times 0.79, that's 158. I take 158 times 0.79 and get a number, and then that number times 0.79, you get another number. So you just keep multiplying by 0.79, and you will get a table that looks like this. Right? We're just multiply by 0.79, multiply by 0.79, multiply by 0.79, and that's it. Okay, does the function model exponential growth or decay? This rate is less than 1, so it's decay. What does that value of 0.79 mean in the context of the problem? Well, what are we doing here? Well, H is the amount of medicine. H is the hours after you consume something. and then like some medicine. And then M is the amount of medicine you have in your body after H hours, right? So that's what we're talking about. So the 0.79 tells you like how much medicine is left in the body, like what percentage is left in the body after every hour. So when I look at my chart, when I took the medicine, it was like 200 milligrams of something, let's say. After 1 hour, I only had 70, what was it? 79%, 79% of that left over. So I had 158 milligrams in my body, or whatever it is they're measuring. And then after another hour, I have 79% of that left over in my body, et cetera, right? So it's 79% leftover medicine every single hour. And you can see they explain that here, right? Every hour, the amount of medicine is 79% of what it was before. All right, a couple to go, and then we're almost done. Okay, so they're attempting to identify the range of the function. So here we have this function. One person says greater than 30, and the other person says greater than or equal to 30. So which is correct? Well, we've been talking about this number giving us the asymptote, and that's why they use 30. So they're actually correct about the 30. It's just, should it be the equal to or not equal to? Remember, the asymptote is something that doesn't get touched. You approach it, you get closer and closer to it, but you never actually cross it. So we don't use the equal to part. We don't. This is the correct one. So John is actually correct. We never actually touch the asymptote. We just get closer and closer to it. Okay, consider the exponential functions. Which characteristics are different? And they're talking about these down here. So remember, like, I'm just going to do a really quick sketch. So the first one, I'm starting at 16, and I'm just zooming up at a rate of 9, which is really fast. And on the other side, I'm approaching the asymptote of 0. Okay. This one has a rate that's less than 1. So I'm starting at 1, and I'm going to decay, but I'm still approaching the y-intercept of 0. Right? There's nothing shifted here. There's nothing shifted here. So my y equals 0 is my asymptote. All right. So is the range different for these? Well, the range are the y values, right? So yeah, the range, the range is not different because they both have the same asymptote. They're both above y equals 0. So no, they're the same. They're both y is greater than 0. That's the range for both of them. Is the domain different? No, they both go to the left. They both go to the right. They both have all real numbers for the domain. They go negative infinity to infinity, both of them. So no, there's no difference. Is their y-intercepts the difference? Well, yeah, this one has a y-intercept of 16. This one has a y-intercept of 1, which is here. So yes, the y-intercepts are different. Is the asymptote different? No, they both have the same horizontal asymptote at y equals 0. So that's the same too. So number 3 is the only one that's different. The y-intercept's different. Okie doke. Let me pop up the answers just to show what they wrote. There's number 7 and number 8. All right, let's go to number 9. We just have a couple left and then we're almost done. Oops, wrong one. All right, number 9, write the equation. Okay, so this is the one before where I was telling you that we're going to have shifting along with our y-intercept, and it's kind of messing things up. So basic equation. Sorry, I'm just writing this out in full. All right, so that's basic equation, but with the shifting, and I need to figure out what these numbers are. It's tempting to say that I know what A is, but I don't, because I can't really see what that y-intercept is. And on top of that, the A is not really that y-intercept anyway. Remember, A plus K, and then also it gets shifted left or right. So like the K, the H, and the A all play a role in where the points go and where the y-intercept is and stuff like that. So I don't really think about that. Here's what I do. I look at this first and I go, where is the asymptote? And I can see that my asymptote is still at 0, right? That's where this is approaching 0. Oh, so that helps out. Why? Because this is plus 0 now. In other words, I don't need it. So the K value is 0. The shifting up and down is 0. That really helps. That helps. All right, is the shifting left and right 0? I don't think so. I think we're actually going to shift this to the right or something. So let's take a look. Is there a way I can figure things out? Like we're going to try and give you easy enough ones that you might be able to just figure them out by kind of logically thinking it through. And this is one of those. But I'll show you the other way as well. One way to look at that is like, okay, if I'm at 12 when it's 1, then if I go over and I multiply by some number, and then I go over and I multiply by the same number, what number do I have to multiply by? Like 12 times what gives me this number, whatever that is, and then that number times the same number again, right? I'm trying to think out what the rate has to be. So times some number and then times the same number again to get to 108. Let's just try one so you see what I'm talking about. What if I took 12 and I multiply by 2? 12 times 2 is 24. If I take 24 times 2, I'm going to get 48. Oh, well, that's not 108. Why am I going 2 jumps? Because I know I'm going from where this is 1 to 3. So that's like 2 time periods, right? From 1 to 3. All right, so 12 times 2 times 2 doesn't work. What about 12 times 3 times 3? Well, 12 times 3 is 36. And if you take 36 times 3, that's 90 plus 18. That's 108. Oh, so that actually works. So just logically, I figured out that the rate has to be 3. Whoops, I kind of erased this. I didn't want to. Okay, so that's 3. I can put that in, right? Sorry. And then 3 raised to the power, right? I don't know if I have a shifting or not, or have a like shifting left and right. I don't know. Maybe I do, maybe I don't. You can put in points into this. So like if I want to try, like let me just assume it doesn't shift. Let's see if we can make it work. So if I put in 12 for my y value, which means that x is 1, right? I'm just using this point and plugging it in, putting in a 1, putting in 12, and then I can solve for a. So I can see that a has to be 4, because when you solve that, you get a is 4, right? 12 divided by 3. So that should work, but I kind of want to test it with my other point. So if a is 4 and my rate is 3 and I don't have any shifting at all, then is that going to work, right? So let's take a look. If I take 1 and I put it in for x, that'll give me 12, so that works. If I take 3 and I put it in for x, 3 times 3 times 3, right? That's going to be 27 times 4. Yeah, that's 108 as well. So 3 to the third power times 4 is 108. So that actually works. It seems like my y-intercept is going to be 4. Right down here. It's really hard to see that that's 4, but that's what it is for the y-intercept. It looks like I didn't have any shifting on this. So we made it a little bit easy for the reader. It's possible you have some shifting and you got to think about it and kind of add stuff in there. The asymptote, this horizontal asymptote, will help you with the K part. The shifting left and right, you kind of have to maybe wonder if like this point was shifted over, like the whole graph went over this way or the whole graph went over this way. I thought this one might move over to the right, but it doesn't look like it was. So we'll practice more of those in class, I think. All right, last problem. So this one passes through 0, 5, and 126. Horizontal asymptote at -2. Oh, so this one's shifting. It used to be at 0, but now my horizontal asymptote is at y equals -2. -1, -2. Okay. It passes through the point 0, 5, so that's got a y-intercept of 5, right? And then 126 is also a point, so like 1 and then way up at 26 somewhere. So I can get the shape of this. I can see that it comes down, and it's just going to keep coming down and approaching that asymptote. I didn't really make that very smooth curve. It should have been a nice smooth curve. But yeah, that's the basic idea. It goes through that point, goes through both of those points, and then approaches that asymptote y equals -2. Let's look at the equation. Okay. It looks like I have a shifting up, or sorry, shifting down of -2. So that's going to add into my confusion, right? So I'm going to put on the -2 onto this. All right, they told me my y-intercept is 5. The trouble is it's 5 after it was shifted down to. So what did I have to start with so that after I shifted it down to, it ended up at 5? So the answer to that is 7. So in my brain, I have to logically think out, my y-intercept used to be 7, but because I shifted the whole thing down to, right, with this -2, right, then my asymptote went from 0 down to -2, but my y-intercept used to be up here at 7, and it also shifted down 2 to 5. So that's why I have 0, 5 as my y-intercept, even though 7 is my kind of starting rate. Yeah, before the shifting, right? Before the shifting. So it's a combination, this number and this number. I'm assuming we're not shifting left and right, but let's see what happens. So if I put 0 into this equation, it doesn't matter what b is. Like b to the 0 is going to be 1, and that's going to be 1 times 7 is 7. 7 minus 2 is 5. So it works for the first point. Let's see if we can find b to make it work for the second point. So I'm just going to put 26 into my y value. Like I'm just plugging that second point into my equation. I'm trying to find b, the rate. I know my x is 1 in this case, right? This is a 1 and 26 up here. And then I'm going to shift down 2 or -2. Okay, so let's solve. I have to go 26 plus 2 is 28. And then I have to divide by 7 on both sides. That's ugly. Divide by 7. And that's what my rate is. It's not very, what's 28 divided by 7? That's 4, right? Because 7, 7, and 7, 7, that's 28, right? So that actually equals 4. So 28 over 7 is 4. So it looks like my rate is, or my rate is 4. So let me rewrite this. Y equals starting amount of 7 before the shift. My rate is 4. And then I raise it to the x. And then the whole thing minus 2. So that's my answer. That's my equation. But I kind of want to double check it and be like, what if I put 1 in for 4? Did that really give me 26? So if 1 goes into x, so 4 to the 1 power is 4. 4 times 7 is 28. 28 minus 2 is 26. So that really does work. And it seems to go both through both points, and it's also going to have a asymptote at -2. So it'll shift down to basically from my original. All right, so that one's like paying attention to the asymptote really helps us figure out what that starting amount is. Yeah, and what that A value is, right? The rate you have to get from your points and try to plug those in after you figure everything else out. Let me show you one last thing before we're done the video. There are ways to write simultaneous equations to solve these things. Um, I, I don't want to confuse you with it though, because we don't really expect you to solve simultaneous equations really, but it is possible, especially on the basic ones. Where was that one? The first one I had to do, it was up here somewhere where I had points and I had to write the equation. Oh, this one. No, that's the one I just did. No, this is the one, right? Like it is possible to just like write the equation. Whoa, I didn't want to do that. Undo. Didn't want to do that. Sorry. Ah. Okay, here I am. It is possible to just write the equations with the value, with the points in them. And what I'm trying to find is unknown. I can do that and then also write the other equation. Like I said, I really, maybe I shouldn't even be showing you this because we don't expect you to do this. We don't want you to do this. But you can do something like that and then solve the system of equations. Yeah, that's more of an kind of an algebra thing, like solving systems, right, with linear equations. We don't really want you to do that, but that is a technique that you could kind of use. Trouble is that only works if you don't have any shifting. So that's another reason not to use it. It's because it gets complicated. So we just want you to logically think about what's my rate, what's my asymptote, and all that good stuff. All right. Let me pop this up so you can see the final answers on those last couple, the nice way of writing those. And there we go. That's Waka Waka breaking it down with transformations. This is one of those things that just takes practice. So keep at it. Try some extra worksheets. Maybe watch a different video from Khan Academy or something, or watch my video again. You can try things, right? You can get on your TI Inspire or on Desmos and just write an equation that kind of is in this form and try to think to yourself what that shifting is going to look like and what's the reflection is going to look like. And then graph it out on Desmos and see if you were right, right? You can play around with that and just play with the numbers. There is that Desmos activity we did in class, which practices the whole sliders, right? Shifting things left and right, up and down, and flipping it over. It takes practice. So just make an equation, make a graph, make a graph, make an equation, back and forth until you're good at it. Just like anything else, it takes practice. All right, Waka Waka breaking it down. Ask questions, come see me. Bye.